So we're going to start off by looking at problem number 27 on 2-2. Now we want to find the vertex. And for this here, in standard form, the vertex is given to us by our negative b over 2a, comma, f of negative b over 2a. Because once we find that value, we plug it back into the formula and go from there. Now, our value of b in this case is 3, and the value of a is negative 1.5. Now at this point here, we could do this in the calculator. Negative 3 over 2 times negative 1.5, which is 1. Now we can plug it back in, negative 1.5 times 1 squared, plus 3 times 1 plus 2. Now 1 squared is 1. 1 times 3 is 3 plus 2. Well, negative 1.5 times 1 as well. Negative 1.5. 3 plus 2 is. And this here is, if we add up to it from 1.5 or 1.5 to 5, if I add 0.5 to 1.5, we get 2. And from 2 to 5 is 3. And since 0.5 is bigger, it is 3.5. Now the axis of symmetry is x is equal to 1. Now, one thing, yeah, so it'd just be making sure you plugged it in. How it's plugged in might make a difference. Axis of symmetry, we do have to have it as x equals or y equals. Yes. Yes, remind me later. Now, for the ones that we did for 2-2, all of them are x equals, because all the equations are f of x, y equals a number. And that axis of symmetry is x equals. But for our new equation, the x equals 1 over 4p. The axis of symmetry is y equals k. So there actually is a different axis of symmetry depending on the problem. Does that make sense? So I wasn't too critical on the homework for this here if you didn't include it. I did take points off. You're not the only one. I've had at least 2 or 3 others that didn't include that. So if you just wrote it as this, I will take points off, because the axis of symmetry is not just a number, it's an equation of a line. So 1 is just not even a whole point, it's just a number. But the axis of symmetry is an entire equation of a line. So we need the x equals, or in other case, y equals. No, I was nice for this assignment in that I just took off 1.5 points, especially if you left it off all of them. I didn't reduce or take off points per each one, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 problems, and that's, it would almost be somewhere a third or so, or a quarter of each one. So that would have been technically like 3 or 4 points. So I'm not doing that. Now on the test, I do give points for both, including the x equals and the numbers. So if you do label it right, you will get a point for that. Questions on 27? Okay. I think if you look at this here, 29 is the exact same thing.
Can I see what I did wrong? I think
it might be a value thing. Now 33, I will tell you this here, I'm not going to, I mean, if you look at the formula for 33, what did they write the formula as?
x equals 2, it equals b over 2a. So they have to have negative.
So what did they forget?
The negative.
They forgot the negative.
So we can just say that.
That's the error. Then you need to go back and
Solve it.
fix it. Yeah, so you need to solve it with the correct formula.
Is that still 24?
So everything else, Yeah, everything else is the same. It's just they did not include the negative from the formula. Does that make sense? Because it should be negative b over 2a. They put it as b over 2a. The negative makes a difference. Questions on this here? We have our note sheets from yesterday. Vertex and focus.
Wait, that's A for AEC?
Mm-hmm.
I might have done already.
Ax squared plus bx plus c. General form or standard form for a parabola. Now, we'll look, if we have time, we'll look back at that again. Now, what we're looking at this here. So we want to find the equation of this parabola. Now, there's two that we have. One of them is our x equals 1 over 4p times y minus k squared plus h, and the other is y is equal to 1 over 4p times x minus h squared plus k. Now, looking at these two here, we need to, one, determine which one we're going to use, and then find the values of h, k, and p. Yes? Now, there's two ways we can go about doing this. One of them is how it opens. Now, if we look at this here, is the graph opening up or down or left and right? Left or right? It's opening up, yes? So that means we would be using the y equals 1 over 4p times x minus h squared plus k. We'd be using this formula here. Now, if we weren't given the graph, but we were given the vertex and focus, well, the vertex, point on the graph, and again, for most of the ones we'll do, we're not going to be given the graph, we're being given the points. Vertex is h comma k. Now, the focus, if we're just told the focus is this point, come in one of two general forms. One of them is h plus p comma k, and the other is h comma k plus p, because there's two versions of it, yes? Now, looking at the point they gave us, well, the vertex is telling us that the value of h is what? 4. And the value of k is 2, yes? Vertex, h comma k, 4 comma 2. So h is 4, k is 2. We know that those are true, yes? Now, the focus, so this point is told to us to be 4 comma 11 fourths, yes? Which term changed, the x or y value of the focus from the vertex? Why? Because we need to identify it. But yes, the second value, that y value did change because it went from 2 to 11 fourths, yes? So, would it be the general form of h plus p comma k? Because if it's this one, the second value is just k, yes? But that's saying that k, if this was true, it's saying k is now 11 fourths. But originally we said it was. Does that line up? No, right? Because that value has to change. We have to add something to it, either positive or negative, yes? And our first value is 4. Well, this is saying it's h plus p. It's saying it should be Changing, yes? So it's not the h comma k plus p. Do y'all see that? Because I'm looking to see what value changed in the focus. And then lining it back up with our general forms. Is it going to be our h comma k plus p or our h plus p comma k? Which one's changing? Well, since we see that the second value is changing for the focus, well, I figure out which one that's connected to, which is our y equals 1 over 4p times x minus h squared plus k. Do y'all see how that works? Because this one here, given the focus and vertex, is one of the harder ones to determine because we're having to look at the 2 points and see how is it changing, how is it altering. And I say that because directrix, for one equation, y equals k minus h, yes? The other directrix is x equals h minus p, yes? One is x equals, one is y equals. We can just look and see, what does it have? Does it have x equals or does it have y equals? Okay, then I can pick the equation. Axis symmetry, y equals k. And the other x is equal to h. H and k are just numbers.
So, like, whenever you have a variable to look at the same thing, put y into instead of x, you would say y equals.
So here, the y value changed, yes?
Yeah.
So that means we're looking at this one here, h comma k plus p.
Which aligns with the y.
H comma k plus p lines up with our y equals.
It's always been there. Oh.
And if the x value changes,
It's going to be x
there's going to be the x equals.
h plus.
Yes. Questions on this here? Questions on either so far? Okay. Now, there's a reason behind that because the distance that the focus moves is the value of p. And with our y equals, it's moving the focus straight up from the vertex or straight up and down is our y. So we're adding it to the y or subtracting it from the y. But that subtraction is just because p is negative. On the other one, we're moving it to the left or to the, so we're adding it to the x. That's why it works that way. Questions on this so far? Do we see how that works? Now, the only thing we need to find is the value of p. But I know that k plus p is what?
What? Yeah.
11/4, because that's the y value of the focus. Y value of the focus is k plus p. It tells us it's 11/4, so k plus p is 11/4. Now our k value was told to us to be 2, so 2 plus p is 11/4. Lastly, what do we need to do? Minus 2. So 11/4 minus 2 is 3/4 or 0.75. And lastly, we need to plug it in. So we'll plug 3/4 in for p. So we have 1 over 4 times 3/4 times x minus, well, our h value is 4 plus k, which is 2. Questions on this here? Now our 1 over 4 times 3/4, again, 1 over 4 times 3/4 is 1/3 times x minus 4 squared plus 2. And that's it. Questions on this here? Because really, once we find the values of h, k, and p, we can find the equation. And that's going to be true going the other way as well. To find the information we need, the vertex, axis of symmetry, focus, and directrix, we need the values of h, k, and p. Because if we have those, we can go from one to the other or vice versa. Questions on this here? This slide is missing one little piece of information. Yours has it already. Yes? Y equals. Now again, with any of these here, finding the equation, well, we still need the values of h, k, and p. And again, the vertex is still h, comma, k, because those are just universal for this here. Now, we need to figure out which, well, still universal, since we have the vertex, the value of h is, and the value of k is. Because it doesn't matter which equation we have, vertex is h comma k. H has to be 5, k has to be -1. Yes? Now we need to determine which equation we're going to be using. Well, they told us the directrix was y equals -27/2. Right. So looking at the two of these here, the only one that has a directrix of y equals is this one here. So it just tells us it's the y equals equation, that y equals 1/4p times x minus h squared plus k. Now realistically this is a little different, but I mean, we could do this already because I know what h and k are, yes? We can plug them in. There's really nothing stopping us from plugging it in. We could have done this from the get-go, but since we know these two values, we know we're going to be at this far. What is the only thing we're missing? So even if I didn't know what p was or how to get it, I do have at least 2/3 of the problem done, yes? And even on the ACT, if they asked a question like this, vertex, h, and k, I can line that up and I can get pretty close to the answer. Because luckily with the ACT, unlike this here, they give you multiple choice. Now the directrix general equation was what? Y equals k minus p. And for our problem, we have y equals -27/2. So the y equals do line up, but what does our k minus p line up with? So with our equation, this is the general form of the directrix, yes? So our y equals lines up with our y equals. So the k minus p is lining up with our, so what we're saying is k minus p is over 2. Because when we subtract whatever the value of p is from our k, we should get -27/2. We should get what our directrix value is. Questions on this here? Now what is the value of k? So -1 minus p is -27/2. Now we just need to solve for p. So what is with p right now? The -1, so we would add 1 to both sides, telling us that -p is equal to -27/2 is we still need to simplify because it tells us -p is -25/2. Yes. Now we can get there by dividing both sides by -1 or multiplying both sides by -1. But I really need to change p from negative to positive. If I change the sign on one side, I have to change the sign on the other. So our last part is p, which is 25 over 2. Yeah, we can multiply both sides by -1 because negative p times -1 is positive p. Negative 25 over 2 times -1. The negative and negative makes a positive. And 25 over 2 times 1 is just 25 over 2. Questions on this here? Yeah, you can use either 12.5 or 25 over 2. Either works. Now, the next thing we have to do is plug it in. 1 over 4 times 25 over 2 is 1 over 50. We do 1 over 4 times 12.5, which is 0.02, or 1 over 50. Now inside the parentheses is going to stay x minus 5. So we're not going to leave it as plus -1. We're just going to rewrite it as -1. Questions on any of this here? Are you ready for the next one? The parabola with a vertex of -1, 4 and a focus of -1, 2 is given here. Well, the vertex is still HK, yes? Now we need to determine which value changed from vertex to focus. Did the x value, the first value, change? Or did the y value, the second value? So the y value changed, yes? And if we look back at the general form for y equals, x value is still h, y value is now k plus p. So the y value changed, which means that we're looking at our y equals 1 over 4p times x minus h squared plus k. We're still looking for h, k, and p. And this is h comma a plus p. Now, just from the vertex, what is the value of h? What is the value of k? 4. Because from the vertex, it told us h was -1, k was 4. Now, if we look at the focus, it is still telling us that h is -1. But the second value of the focus is telling us that k plus p is 2. Now looking at this here, what is our value of k? So we're saying 4 plus p is, to get p by itself, we would need 2. Subtract 4. And again, the biggest thing with any of this here is matching it up to the general forms and finding our piece of information, our h, k, and p, because once we find these, we can plug them back in, telling us y is equal to 1 over 4 times p, which is -2, parentheses x minus h, in our case is -1, plus our k value of 4. Now we do need to simplify our 1 over 4 times -2. Well, 1 over 4 times -2 is, be helpful if I put -1/8. Now inside our parentheses, our x minus -1, negative, and a negative make a plus. So we get y equals -1/8 times x plus 1 squared plus 4. Questions on this here? Questions on any of this here so far? Are we getting a little more comfortable with this here? Yeah. Because would y'all say that there is a lot going on with these problems? Is there a lot of stuff we're doing? Especially, I mean, not compared to our 3 variable systems. That had a lot more steps, a lot more work, a lot more things to it. Here, we have several different components. There is a lot of stuff up there. But what we're looking at to find the equation is really 2 pieces of information and then connecting those back to each other. Because if we can do that, we can find the equation pretty easily. Questions on any of this here so far? Now for this one here, the vertex. Well, that's still h comma k, yes? Our directrix is y equals 73/8 here. Now again, just like all the problems we've been doing, we need to find the values of h, k, and p. Well, and after we do that, we also need to find the equation that it connects to, yes? Well, so h, k, p. Now since it gave us the directrix, this is a little bit easier to pick the correct equation, yes? Because there's only one of the 2 equations that has y equals, yes? For the directrix, which is actually y equals. Because if I look back at this here, this directrix is y equals, this one is x equals. Since it told us the directrix was y equals, I find which one that connects with, and it is our y equals 1/4p times x minus h squared plus k. Now the vertex told us the value of h is, the value of k is, but it didn't tell us the value of p. Now in the general form, our directrix is y is equal to k minus p. So for us here, k minus p's value should be what? So what does it line up with our directrix? So it's not 1, it would be. So directrix. Y equals, in the general form, k minus p, yes? So in the equation, or the information they gave us, what is the directrix value? So for us here, the k minus p should equal, yeah. Let's see. Okay. So we get 73/8, yes? So our k minus p is 73/8. Well, what is the value of k? 9. So we're saying 9 minus the p value should give me 73/8, yes? So to get p by itself, we would, telling us negative p is equal to, so you should get 0.125. There you go. Yes, or
-1.
just 1/8, as it's positive.
I don't know where I got.
So let's see what we get. So we subtracted it, we got 1/8, or positive 0.125. So negative p is actually equal to positive 1/8. But to get p by itself, we would need to multiply both sides by -1 or divide both sides by -1, telling us p is negative 1/8.
I know it's like equals. Well, I said that p is 18.125.
Yeah, I just don't know where you got the negative 18.125.
I think I was trying to set it up weird. Like,
Questions on how we got p? We feel good about finding p for this year.
wait, 9 minus 18. I was plugging random numbers in.
Okay. Now we just need to plug it back in. So we get 1 over 4 times negative 1/8 times x minus h, where h value in this case is 8, plus our k value, which is 9. Now the first thing we need to simplify is our 1 over 4 times negative 1/8. So 1 over 4 parentheses negative 1/8 is negative 2.
Another one just like that. I got lost.
So we get this here. Another one with the direct 6.
Yeah.
We're ready to look at the next one. Okay, it doesn't look like we have.
Can I write it down?
Yeah, so this one has vertex and focus. The next one does have directrix, but it's directrix and focus. We'll look at it tomorrow, but we will still have a few more.
So no homework today?
Now, I am giving you the homework sheet.
Oh.
So the ones that we've been doing? Yeah. I'm going to go on and give you this here so that you have it. Now, 1 through 4 we haven't covered those yet. We'll be covering those tomorrow. But 5 through 8 are the ones we've been doing. Now, when we look at this one here, we are given the vertex, h comma k. And to find the equation, we still need to find the values of h, k, and p. Now, without knowing which equation we have, we still know that the value of h is negative 8. The value of k is negative 9. Now, we need to determine which equation it is based off of how the point changes from the vertex to the focus. Does the first value, the x value, change, or does the y value, the second value, change? The x. So the x value of the focus should not be h, but h plus comma k. Because for the focus, we're either having h plus p comma k or h comma k plus p. We're adding p to one of the two values. And if we look at these two here, well, the x value of the focus changes when we have our x equals equation. So for this here, our equation is our x equals 1 over 4p times y minus k squared plus h. But it's also telling us that h plus p is equal to over 4. questions on how we set this up? Questions on how we've done any of this here so far? Now, one of the things I will say, this is similar to when we're given the directrix, but instead of given a point, we're just given a number. Now, the h value in our case is -8. Now, to get p by itself, we're going to add 8 to both sides. So -31 over 4, -31 over 4 plus 8 is, so the value p is 1 over 4. Now we can plug all this back in. We'd say x is equal to 1 over 4 times our value p, which is 1/4, times y minus k, well, our k value is -9, plus our h value, which is -8. So x equals. Now we do need to simplify our 1 over 4 times 1/4. So our 1 over 4 parentheses 4th is 1. So we can write it in as 1 times. We don't necessarily need it, but we can put it in there. Now our minus -9 is the same as close parentheses squared. And our plus -8 is, and that's it. Now we don't necessarily need the 1. You can leave it if you want. You can also, yeah, 1 times our set of parentheses, just same as the parentheses by themselves. Questions on any of this here? Now again, we will pick this up tomorrow. I went on and gave you the worksheet for this assignment. So if you want to go on and start working on problems 5 through 8, you can. Problems 1 through 4 we will tackle tomorrow. We'll work on those tomorrow.